All right, so last time we looked at the trend of the atomic radius, so the distance from the center of my atom all the way to the outermost electron shell. That would be my radius. And we saw that atomic radius increased as I moved down the periodic table and to the left. This time we're going to be talking about the second trend, which is ionization energy. All right, we're going to talk, it's a new word, but we're going to talk about what that means and how we can figure out how it changes across the periodic table. So, ionization energy, all it means is the amount of energy it would take to remove an electron from an atom. So if I had a picture like a Bohr model, right, how much energy would it take for me to pluck off one of those electrons? Big question you want to think to yourself, maybe try and answer on your own right now, is would it be easier to take an electron from the center of the atom or a valence electron, so one that's on the way outside of your atom? So if you want to pause the video to think and try and answer that question, please do, but let's think about it for a second. Electrons have this negative charge, and my nucleus has this positive charge from the protons that are inside of it. So if I had two magnets, some this close together, and some that were this close together, which one is it going to be easier to pull away? Probably the one that's farther away. So it would be a lot easier for me to remove a valence electron than it would be for me to try and go to the center of the atom and pull one of those electrons out that's more strongly attracted to the nucleus. So, easy way to kind of remember this, which electron's going to be easy to pluck off when it comes to ionization energy, is penguins. That's what I think of. So, penguins, right, they make this cute little huddle right here. The penguins on the outsides are the ones that get, pushed in the water, or the ones that get kind of sent off. So, same thing with electrons. The ones on the outside are the easier ones to give away, to kind of push out. But that's just my little analogy as I think about the penguins. So, it's easier to remove electrons on the outside of my atom. That means they have a lower ionization energy. It takes less energy for me to pull those electrons off. And that is partly kind of the fancy term we use for what I was just talking about, that weaker attraction, is electron shielding. So electrons in an atom can shield each other from the pull of the nucleus, right? Those valence electrons are far away. They're being shielded by all those other energy levels that went before them. So the more electron shells there are, the greater this effect experienced by those valence electrons. AKA, to summarize that, the more space there is between the valence electrons and the nucleus, the weaker the attraction is, the easier it is to remove them. So the lower ionization energy they'll have. How we can look about this as far as trend goes is, as I move up the periodic table, my ionization energy is going to increase. It's going to take more energy for me to pull them off. And the reason being is, we know that as I go down the periodic table, I get more and more energy levels. Right? Row 1 has 1 energy level. Row 2 have 2. 3 has 3, 4 has 4, and so on. So the less energy levels I have, the less shielding there is, the harder it's going to be to pull off those electrons. So my ionization energy increases the less energy levels I have, or as I go up the periodic table. It also increases as I move to the right on my periodic table. And you might be thinking, okay, well, why is that? So the reason for that has to do with the number of electrons. So we know our group 1, right, column 1 elements have 1 valence electron, versus over here, these guys have 8. Having those 8 electrons is going to make them have a stronger pull on the nucleus. They're going to be harder to remove. So these have more electrons to deal with than these ones over here would. So as I move to the right, it's going to take more energy to pull those electrons off. And that is my trend for this topic, ionization energy. Increases moving up and to the right. The exact opposite of my atomic radius, which increased going down into the left. So they kind of have that correlation there that goes with them. But key ideas from this video are, it takes more energy for the less shells that I have, the less energy levels that I have, because there's less shielding that way. And it increases to the right because of my amount of electrons that I have pulling on the nucleus. And that is it for ionization energy. Next time, we're going to be looking at some graphing trends with both of these. So, I will see you then.